Our fourth lesson is calculate inherent uncertainty. With inherent uncertainty, it'd be nice to be able to state how much inherent uncertainty we have at key points in our development process. Are there ways to calculate and articulate how much common cause variation our process typically has? Let's take a look at one way to do this on a work effort. Let's say I have a project. I'll call it Project Framus. I'm at the start of this project. My initial estimate is for 7 months of time. This is not my only estimate of Framus. I have several points in the project where I will redo my estimate for the entire project. Okay, I've completed some work. I now am at point one of my project. I know more now than when I started, so I'll revise my total project estimate to 11 months. More time and more work goes by, and now I'm at point two. Learning more, I revise my total project estimate to 10 months. More time, more work, more learning, and at point three, I revise my total project estimate to 9 months. The pattern continues at point four, where the total project estimate is now 9.5 months. I finally get to project completion and I record the actual time. Frameless took 10 months. I calculate the balance of relative error. I can see that I was off by various amounts. Well, at point two, I was smack on. At the other points, I was off by various amounts. I can take those numbers and plot them on a graph. You can see that the plot is kind of interesting, but I've only done it once. If I plot other projects for my organization, I can come up with something even more interesting. Here you can start to see a pattern. If I draw the boundaries of that pattern, I start to get a sense of my inherent uncertainty, the inherent uncertainty that my organization deals with due to common cause variation. This variation is just the nature of how we do work. A person named Barry Boehm actually came up with an initial set of numbers for inherent uncertainty. As I understand it, his first numbers were more based on his intuition. But then he got some real data from projects that showed that his intuition was pretty close. This is his data on the graph. His data was from well controlled projects with professional estimators. His data shows that software intensive projects tend to have maybe a 16x variation around those early estimates. Now, there's a couple things about his numbers that we need to be aware of. One is that this was before Agile, so you can see a sequential development process suggested in these points. Also, the spacing between the development points is roughly equivalent, suggesting a time equivalency that it just isn't true. Heck, detailed design complete is practically at the end of the spacing. I don't think that represents a sequential project very well either. But I do want to point out that early on here we have a wide variation, the very wide part of the cone. If we draw this to reflect development activities on most projects, including Agile projects, with time on the x-axis, you'll see a graph that looks more like this. I like to call it the martini glass of uncertainty. The martini glass's rapid narrowing is more typical of what we'll see on well-run software projects. They start very wide at the beginning, quickly narrow as we make some of those early core decisions about the project. Now, this cone is the best theoretical shape. Most cones are not symmetrical given our bias to optimism. Also, you can have a more typically run project and have a cloud of uncertainty. That's just nasty. I joke of once seeing a cylinder of uncertainty. No one had any clear idea of the entire project and of how long it was going to be until it was canceled. Then they knew. Because we have to actually do the work if we're going to narrow the cone, playing around, trying out things, being inconsistent, changing priorities, changing direction, we can create lots of uncertainty throughout the life of a project. And the cone is just not software projects. We looked at a version of a study guide from the Project Management Institute, PMI, and these are the points they identified where they made decisions. If you look at the budget estimate, you're almost a third of the way through. And that definitive estimate, the one that you could say, yes, we'll be within plus or minus 10%, is halfway through a normal development effort. This pattern repeats itself all over the place. Some clients share estimation data with us as we help them improve their estimation practices. Here, we plotted out 350 different estimates from 5 different companies, and you can see a strong optimism bias. They are underestimated far more than they overestimated. 7 times for underestimation, 1.2 ish times for overestimation at the start. A strong bias to underestimation. The median, the number in the middle of the data set, also shows the optimism bias. And these are people that we had taught estimation to, and they were doing better than average overall because, hey, they even knew to collect this data. These graphs are presented in terms of time or cost. Is the cone also true for scope? Because one of the things, if we're doing agile and we're doing agile estimates well, is that we want to fix the schedule and put our uncertainty on scope. Does the cone of uncertainty describe that too? Well, here's a set of prioritized features or stories or whatever you want to call them, and they have a best case and a worst case estimate. It's going to take at least this many hours, minutes, days, months, or whatever units you want, and the worst case could take up a higher number. Let's say we had 35 units, hour, days, months, whatever, that we had available in this release. We say, okay, what features are we going to get in the fixed 35 units? Well, if everything goes well, we'll get to the first 7 priority items. But if everything goes poorly, all the risk and uncertainty bites us, we'll only get to the first 3. We can see it mapped out like this. At the beginning of my work effort, if I look across my 6 sprints, my backlog has this much work to be done, as described by the yellow here. Each bar represents a total project backlog. However, if you ask me for an estimate from what estimate at the beginning, what we'll do from the backlog and be there by the end of sprint 6, well, you know what? If things are going really, really poorly, I'm only going to get this much in at the green at the top. So what I can commit to, the first 3 features. And if things go really, really well, this stuff in the red is still not going to make it. I have my in, my out, and the rest of the stuff is, well, maybe. It depends. It depends how well things go. On sprint 2, I now know how well sprint 1 went, so I'll revise my estimate of how much the backlog will be available after sprint 6. More is going to be in, but more is also likely to be out. And this process repeats itself as I go through the entire sprint. And lo and behold, what do I have again? The cone of uncertainty. I think there are 4 notes you can walk away from this lesson. First, our outcomes can be easily worse than the cone. If we don't do the work necessary to move the project forward, we will not lower the inherent uncertainty. Also, that the cone represents the amount of estimation precision we can have. Stating a single point when the cone has a 16x variance makes no sense. Trying to be more precise than what the cone tells me is possible alerts me that we're probably incorrect. I once went to New York and saw the barometric pressure to 14 decimal places on the weather page. I knew that was wrong. Someone can exhale and change that number. High precision often really tells you that someone doesn't really know what the estimate is. For that reason, commitments are not very useful early in the cone. If I want to make a commitment, I'll have to commit to one of the extremes of the cone, which is a number you don't want to hear. I think it's going to take a month, but given the inherent uncertainty, I'm going to tell you I can commit at 6 months. You don't want to hear that when you also know it's only about a month's worth of work. I can make plans early around that month, but I cannot commit to it. I need to do the work to narrow the cone to where the inherent uncertainty is low enough that I can make a useful commitment. Finally, narrowing the cone is doing the work of the project. You cannot do planning exercises to narrow the cone. You cannot have deep thoughts to narrow the cone. You must start work and re-estimate along the way. We need our business partners to know when we have narrowed enough to make a useful commitment.